So we have learned about Ohm's law. So how the current and voltage depend, how they behave when we have one single resistor connected to the power source. Today we'll look into the combination of resistors. So we have two or more resistors connected to the power source. So we're looking today into the parallel and series connection. So what is series connection? When resistors are connected one after another. So one resistor, and second resistor, and let's say we have a power source. That is series connection, when one after another. The parallel connection is when we have both ends of the resistors connected together, and then it's connected to the power source. So that's series connection, and one after another, and this is a parallel connection. And let's have a look how current and voltage behave in each, and what happens with the overall equivalent total resistance in each of those arrangements. Let's start from series connection. And so which line, long or short, represent positive terminal?
Long.
Long, positive. So what is the direction of the current? What do you take as direction of the current? From
Right to left.
From positive
To negative.
to negative. But where the actual electrons moving,
Connection to series.
The other way.
they're moving from negative to positive. So there is only one pathway for electrons. So if you have, let's say, 1,000 electrons, left negative terminal of the battery, there is only one way how they can move to get back to positive. So all 1,000 electrons will come through this resistor, all 1,000 electrons will come through this resistor. There is only one pathway for electrons. So that will be same amount of charge coming through each resistor. That means current, which is charge per second. So if this is resistor R1, this is resistor R2, we will have the current in the whole circuit will be same through resistor 1 and same through resistor 2. So in series connection, current is the same. In each resistor, current is the same. Let's see what happens with the voltages. Let's apply. So we have, let's say, all voltage provided by the power source is V, and we have voltage drop, potential difference across first resistor V1 across second V2. Let's recall what is voltage. What is the definition of the voltage?
Difference between 2 volts. Points.
It is amount of energy.
Needed to push from one point to another.
Excellent. It's amount of energy needed to push unit of charge from one point to another. So let's have, we have point 1, point 2, point 3. So how much energy needed to push from point 1 to point 2 through the resistor R1 will be V1. Then from 2 to 3 will be V2 will be amount of energy needed to push current through. So how we'll find total? We need to add them. Because as much energy we use here plus as much here, that will give us total energy. So we have for the series connection voltage equals sum of the voltages. Drops across each of them. So voltages across each of the resistors connected in series adds up to the total voltage supplied. Now let's rewrite each of them using Ohm's law. We have IR, with voltage equal current times resistance, equal I1 R1 plus I2 R2. The Ohm's law for the first resistor, Ohm's law for second resistor. But we already established that currents are the same. Current here, same as current through first resistor, same as current through second resistor. So we can divide its same number, so we can cancel it out, and we'll have that total or equivalent resistance will be sum of all resistors. And that will be the case if we have not only 2 resistors, if we have 3, 4, 5, 50. If they all connected in series, total resistance will be sum of the resistances of each resistor. Simple example. Let's say we have connected voltage 9 volts, and we have resistor 1 equal, let's say, 6 ohms. Resistor 1 is 6 ohms, equal 6 ohms. And resistor 2 will be equal 12 ohms. 2 equal 12 ohms. What will be the first total resistance of this circuit? Yes?
18 ohms.
Yeah, we just add them. 6 plus 12 will be total, will be 18 ohms. Now, what, because we add, yes?
No, when you say that there's 9 volts from the power source, does that mean it's 9 volts for the entire circuit? Or
Yes. Yes. Now, what will be the current? How we can find current in this circuit? Using Ohm's law, we have total current will be equal voltage supplied over total resistance 18 equals 0.5 amps. Make sense? To find current, we divide voltage by the resistance. What will be the voltage across resistor 1? How we can find it? Using Ohm's law. Current through each of them is the same, is 0.5 amps. Times resistor 1. This is I times R, current times resistance, will be equals 3 volts. So we have voltage drop across resistor 1 is 3 volts. What will be voltage across resistor 2? 0.5 times 12 equals 6 volts. And what we can see, that voltage, if we add voltage across R1 and voltage across R2, we will get total voltage 9 volts. Make sense how series connection works? Let's have a look into the parallel connection. Now, what will be voltage or potential difference across resistor R1? If you have total voltage supply V, what will be the voltage drop across resistor 1? Yeah, V1, but what it will be in terms of this V? Yes?
Half.
Can you see this resistor is connected, this end connected to the negative terminal, this end connected to the positive. So all voltage will be across R1. And same will be for R2, all voltage will be across, because we have this directly connected to the power source. And again, if you recall definition of the voltage, amount of energy to move unit of charge from point 2 to point 1 to point 2. For both resistors R1 and R2, it's the same point. So we move, it doesn't matter which way we're moving. Either we're moving this way or we're moving this way, we start and finish at the same point. So we'll need to use the same amount of energy. So in parallel connection, voltages are the same. Because they connected to the same point. So between those points is the same potential difference. Because points are the same and they both connected directly to the power supply. Yes?
Is that why in the track yesterday when they were parallel they were so metal like this?
Yes? Yes? Good observation. So, they're the voltages. Now, what we can say about the current? If we have current I, total current that came from the battery. Here it will split. Some electrons will move through resistor 1, some move through resistor 2. But the total number of electrons moving through the circuit stay the same. So we will have the total current equals I1 plus I2. There are two ways for electrons. So total, let's say two rods, we have one rod is split in two. We have number of cars coming from there. Here they split and move through two rods, but the number of the cars is still the same. So total current, it splits here, adds up to, so current through 1 plus current through 2 adds up to the total current.
And
Yes.
is the current between both points like split equal? Is it equal?
If resistors are the same, yes. If they're not the same,
If not, then
no. It's like one rod will be narrow, another rod will be wide. The wide rod can more cars go through. Now let's apply apply Ohm's law to this. I will be V over R equal V over R1 plus V over R2. I'm writing V because V1, V2 both equals V. We can cancel voltage and we get formula connecting total resistance with the resistance of each resistor connected in parallel. 1 over R over total or equivalent resistance equal 1 over R1 plus 1 over R2. Let's consider the next example. If we have both are the same, we take two resistors, R1 equals R2, each of them equal 100 ohms. What will be the total resistance?
50.
Yes, will be 50. how we can see if we do 1 on R equal 1 on 100 plus 1 on 100 equals 2 on 100, which is 1 on 50. But that is not resistance, it's 1 over resistance. If 1 over resistance equals 1 on 50, what resistance equal?
50.
50. 1 on R equals 1 on 50, R equals 50. Make sense? So, you see, when we can connect resistors in series, overall resistance increase. But when we connect resistors in parallel, the total resistance decrease. Can you tell me what will be if we take 4 resistors, each of 100 ohms, and all 4 we will connect in parallel? What will be the total resistance? If we connect 4 100 resistors, we connect them,
25.
yeah, 25, yeah.
I said that before.
We connect them in parallel, the total will be 25. If we connect 10 resistors in parallel,
10.
will be 10. Make sense? So as more, it's like connecting more resistors in parallel, it's like making more road for electrons to get through. So resistance becomes smaller. And let's do one example with calculation. So if we have voltage again, we take voltage 9 volts. We have resistor R1, we will have 6 ohms, and this we have 12 ohms. First, let's find what will be the total resistance. 1 on R equal 1 on 6 plus 1 on 12. Bring to common denominator, which is 12. So we'll have 3 on 12. So what R, if 1 over R equals 3 over 12, or,
One is 4.
so this simplifies to 1/4, R equals 4 ohms. So you see the total or equivalent resistance will be smaller than the smallest resistor connected in parallel. So we got 4 ohms. Now what will be the current now? What will be the total current?
Will be 9 over 4.
Will be 9 volts over 4 ohms, will be so 2.25 amps. And let's find what will be the current through each resistor. What will be the current through each resistor? We have voltage across R1 is 9 volts. So I1 equal voltage across is 9 volts over resistance 6 will be equal 1.5 amps. I2, current through second one, same voltage 9 over resistance 12 will be equal 0.75 amps. If we add 1.5 and 0.75, they will add up to 2.25. So when resistors are not the same, current split not evenly. Through each resistor will have more current, through smaller resistance or bigger resistance. The smaller resistance, the bigger will be current. Through 6 ohms we have 1.5 amps. Through 12 ohms we have 0.75. That's pretty much all theory of the series and parallel connection. Now we will do some practice with it.